Hello everybody and welcome to this Touchdesigner tutorial, and in this one I'm going to show you how we can use the field pop to really locate and create distortion on a point cloud in a really localized way. So on the left part you can see we are applying the modification as the ball is going through the kind of glass material, and on the right one we are doing twisting and noise modification on point cloud, photogrammetric point cloud, and we can change where we want to apply it in a really simple way. So we are going today in this tutorial to recreate the model on the left, and the model on the right will be available on my Patreon, but it's basically the same technique we are using, the same logic. The only difference is the one on the right is using a twist, and yeah, that's pretty much the biggest difference. So you can find both on my Patreon. And as usual, even if you download the file, I recommend you to follow up the tutorial so you understand the logic behind it, and it will be easier for you to tweak the different parameters. So that's pretty much it for the introduction. Let's start a new project and rebuild the one on the left from scratch. So here we are in a new project, and the first thing I want to do is to create point cloud. We are going to modify it. So first thing first, let's go to the pop and in point generator, and point generator, not point filing. And in point generator, I'm going to go for box with a size of 4 by 4 by 0.2, and number of point, let's increase it a lot, like 50,000 or 500,000. Yeah, to have something way more dense. And I'm going straight to it to connect it to a geo and to create a small render setup with a camera, a render top, linked to a RGB key top. So we have it in the background, and the camera I'm going to go a bit on the side like that, something like that, and then add a material to our geo so we can see it better. And I'm going to use a point sprite and lower down the alpha in common blending transparency on. So now we have our shape we want to modify. So in order to modify that, there will be several options. So if, for instance, I want to apply a noise to this point cloud, we can see the noise is happening all in the full surface, and what I want is only to apply it on one part. So a solution could be to add a delete here, a delete pop, and in bounding I could choose enable and choose bounding sphere, and you can see it's deleting all the particles that are inside this sphere. And if I invert it, we only keep the one that are inside the sphere. So we could do something like that, then copy past this one, use it here, and not keep it inverted. And then here we have quite the opposite. We have the one who are not affected by noise, and here we have the one affected by noise, and then we could merge both of them. And you can see we would have the effect of only have one part being affected. The issue is first it uses a lot of different operation, and as well we don't have scaling of the noise or scaling of the transformation. That's why the field pop is really powerful. So let's just delete all of this and instead put field pop. And so you can see in the field pop we have different parameters, and in the field here we have the mod, sphere, box. We have different possibility of geometry to affect our surface. And if you look we cannot see much, but if I put here a dot, I always like to connect it to a dot so we can see what has been created. And you can see now we have the coordinates of our points, normals and such, and we have something called weight, and sometimes it's 0 and sometimes it's 1. So basically when it's 1, it means the weight is at the maximum, and it's because the points are located within the sphere here. So you can see if we increase the radius, everything is going to be 1 because everything is going to be inside the sphere. And so basically now it's like it's either in, either out, but then we have transition range. And if we play on this, we can then have like scaling. And this is exactly what we did not have with the delete solution. So let's use this. And so in order like to see where our field is, what I'm going to create is a sphere. And the sphere, I'm going to locate it in the same position than our field. So for that, first, I'm going to store like the data, the position of our field into a constant. And I'm going to collect tx, ty, and tz. And link this to a null, call it null pos, and use this to drive the transform part of our field. And then we can create a sphere, pop sphere, for instance. Link it to a transform. So we can like transform it according to the field. We could transform it in here, directly in the translate page of our sphere. But for instance, if we want to change like to another shape, we don't have then to change everything. We can just replace the sphere by something else, and the transform will still be applied. So let's put it there. So now we have a way like to visualize where our field is operating. So if here I change, I can see where it's happening. So maybe like we can visualize it like in our geo. So let's add a geo there. And this is our sphere. Let's maybe for now add a constant. And here, let's go for wireframe. So we can really see where it's applying. Maybe change the color to something a bit different, yellow. So we can really see where the field now is acting. So now we have a nice way to see where our field is going to operate within the space. What first I want to do is like to increase a little bit like some resolution here, so it's a bit nicer to watch. So now if we add noise after our field top, what's going to happen is like as before, like it's going to be put everywhere, but here if I choose weight, you can see it's only going to be where our field operator is. I can animate the noise a bit with apps time.seconds in the translate x parameters multiplied by 0.1. Oops, I mean pause. But yeah, you can see like it's not really what we want. Like it's moving everywhere, and it's so yeah, it's not really what I want. I want still the noise like to be added like to the position, but only where the field is. So here I'm going to go back to P. And again, a nice way like to visualize is to use pop to dot. So just be careful when you do that, because sometimes it can really overload the system. You can see like my FPS like will probably drop a lot just by watching it, because we are generating a lot of data. But so you can see we have the weight, and what I would like is to multiply our noise with the weight and add it to the position. And so here in output, I don't want to add, I want none, but I want to output noise. So I'm going to click on noise, and you can see here, now I have noise value being exported. So this is exactly what I want. I'm going to delete this pop, so we are back on FPS. And in order to do so, I'm going to use a mat combine. And the mat combine allows us like to make several operations within only one pop. And using like as a scope, like we can use attributes or constant or like a lot of different things. So the first thing I want to do is like to have the noise being multiplied by the field value, the weight value. So the more within the sphere we are, the more the noise is going to act. So I'm going to choose A multiplied by B. And scope A, I'm going to choose weight. So we are taking the weight in consideration and we multiply it by noise. Oh, let's do the opposite. So because noise is like 3 parameters and weight is only 1. And so the result scope is going to be, we can call it weighted noise. And this weighted noise, I want to add it in my position of my particle. So the more we are in the circle, the more we add noise to the initial position. So I'm going to add another operation. And this time I'm going to choose A plus B. Scope A is going to be the position, and scope B is going to be the weighted noise. And the output, I want it to be the final position. And here we are. You can see we have it working. So let's diminish a bit like the alpha here. So we can just see a little bit. And yeah, you can see like it's working. We have our noise being only displacing where our field is. So let's change a few parameters in our noise. Let's go like for a smaller period, maybe 0.5. And then in our field here, you can see we have transition range. So if we put at 0, you can see like we are really like displacing according to where we are. And as much as we go, it's going to add like some transition, and we can as well change this parameter here to have something a bit smoother, like to change where it starts the smoothing. I'm not sure if I'm clear. Hopefully I am. And then we can choose a transition. So I can here maybe choose linear. So this is a bit the first step of what I wanted. Now let's change this sphere to be like the ball I was talking to you at the beginning. So here, let's not use a constant, but instead let's use a PBR. So now it's fully dark, and here maybe I'm going to increase a bit the frequency to something like, so it's smoother, and I'm going to reduce as well the scale, so it's just like a small part of the field. So then I want to add an environment light to light up our PBR. Oops, sorry, not CAM, environment light. And for that I need like an environment map, and I'm going to create it using a top noise. Like common, I'm going to use 1920 by 1080. And maybe in transform, I want something more stretched and a bit more offset. And I'm going to drag and drop this noise on the environment map. And here I can maybe play a bit with the roughness. Maybe there's too much light here, like something like that. Yeah, I think it's better. And I want it like to go back and forth on the z-axis. So here I'm going to use an LFO, link it to a null. And the LFO you see has an amplitude of 1, meaning like it's going to be +1 to -1. And frequency, I'm going to reduce it to 0.1. So it's getting slower and way slower. And amplitude maybe is something like 1.5. And I'm going to export this to the TZ. So now our ball, you see, is moving, and when it goes through, you can see like it affects the field. So it's working. Like we can see the field is really like depending on how close we are to the object. Now what I would like to have though is kind of deleting the particle which are in the center. So like it kind of open a thing for the ball, open a hole. So here I'm going to insert a delete. And in the delete, I'm going to go to the attribute page and choose weight. And in value, in weight, I'm going to invert it. And so you see like everything disappear. But now if I change the value to something a bit higher, like the more I go, like if I go to 1, nothing will happen. But if I slowly go down, you will see it's creating as it goes a hole in the sphere. So I'm gonna go like for something like 0.5. Yeah, and it's opening as we go through. So this is one thing that can be nice. Now let's see if we can as well kind of play on the color of the particle, so we can modify as well the color as we go through. So first thing to do is to create some colors to our model. So for that, I'm going to use a noise again. And here I'm going to use a lookup texture and reference this noise in it. And what I want to use output oscilloscope, I want to define the color. So here you can see like let's have something a bit like it's rain, so something way more stretched there. So 1 here and 0 here. Yeah, it's working well. Yeah, something like that. And here in the lookup, I'm going to go like lookup annex 0.5 and 0.5, so it doesn't repeat the pattern. So now I would like to have the color fading as our object get closer, or like our field get closer to our object. And in order to do so, I'm again like going to work in the matte combine. So maybe like first like let's get rid of the delete, so we can see better as we go. And to do so, I'm going to multiply the color by 1 minus the weight. So again, like just add like here an operation, and it's going to be A minus B. So 1 minus the weight. And the result scope is going to be, let's call it color weight. And then I'm gonna add another one, and this time it's going to be A multiplied by B. And so if the weight is 0, so if we are far away, we are going to multiply color weight by color by color weight. So it's going to still be 1, and when we get closer, it's going to be a bit more. So yeah, this is a way of having the color slightly fading away, and to have like this bit more natural effect. Going to get back on the delete, and yeah, pretty much it about like the way of doing the color. We could as well like have like something a bit slighter, bigger here. So it's going to increase the color everywhere because we are going to multiply from everywhere. But then it's, yeah, we have more how to say, more range of action. So now I'm quite happy with what we have. I made a bit more room here, like so we can easily select all this, and I'm gonna duplicate it so we can create like a bit more particle trail effect. And to do so, I'm going to duplicate it and insert after the lookup texture. I'm gonna insert here particle operator. And I'm not going to go like in details on how the particle pop work. I did a few tutorial video on it, so feel free to check it. Right now we have a mistake because we need the color attribute, and when we use the particle pops, it kind of deleted the attribute. We didn't pass it by, so like in input we have to choose color. And here in particle, I'm going to increase the maximum number of particles to something like 200,000. Again, if you have like a low-end GPU, or if your system is running a bit hard, yeah, maybe like use a smaller value. And in burst rate, I'm going to go like on frames instead of seconds, and for something really high as well, like 8,000. And yeah, right now nothing is happening because first we have to reinit the system. So let's add a keyboard in shop. Here, so every time I press 1, it will reinit the system. So let's activate the viewer and export in init and start in our particle. And then as well, our particle pops need target feedback operator. So I'm going to insert a null right before our geo and use it for our targeting point. So now you can see we have it. So in order to see better, for now, I'm going to deactivate the geo up there. And so here you can see, yeah, we have something nice. Just in the particle life variance, let's put it to 1 maximum and random seed something random. And so now, yeah, it's working well. Maybe the duration is too long. Let's go like for something like 1.5. And the noise is maybe like too big of an amplitude. Let's go for something like 0.015 and run it. And yeah, we already have something like which work quite better, a bit more organic. Maybe here we can decrease slightly the alpha. Yeah. Let's activate now the first one we had, the first layer. So yeah, it's working quite well. And now if we want to have like the a bit glassy effect we have on the intro, I did. Like here in the first point gen, instead of volume distribution, let's choose surface. And now, yeah, now it's working way better. So I'm not going to go into details about like how to make the camera move around the subject or like to add the 3 layers we had in the introduction. It's quite easy to do, and I'm sure like you can find a way to do it. But yeah, you got like the concept, and you see like how easy it is like to really determine only one part of 3D point cloud we want to work on. So the logic is a bit the same while working with photogrammetry. You can see it in the example, like for the one who are subscribed to my Patreon, so you can download the file with the 3 layers as well as the photogrammetry, but the logic is the same than what we just saw here. Anyway, I hope you enjoyed the tutorial, and you will feel inspired like to make your own creation out of it, and I hope I see you for a next tutorial.